Hello everyone, welcome back to my channel Problematical. We'll be discussing Chapter 2 Polynomials from Class 9th Maths NCERT. In the last class we covered exercise 2.4. Today we'll continue with exercise 2.5. The first question states, use suitable identities to find the following products. Following products means you have to multiply the given factors. In the first question, we have x plus 4 first factor multiplied by another factor x plus 10. Now we know this identity we studied last year as well. We know that x plus a, because both values are positive, so x plus a into x plus b is equals to x squared plus a plus b into x plus ab. All you have to do is identify the values of a and b. This looks something like your given question. So if you equate, it is x plus a, x plus 4. So instead of a, 4 is written. That's why your a value is equals to 4 and your b value is equals to 10 by observation. Here b value is 10. This value is to be placed in the complete equation. So what do you get? X plus 4 into x plus 10 is equals to, in place of x you have as it is, plus in place of a, 4 plus 10 into x plus 4 into 10. This is x squared plus 14x plus 40. And that's your final answer. All you have to do is multiply them, but you have to use a suitable identity. You cannot directly multiply it term by term. So, second question. X plus 8 into x minus 10. Again, you'll use the same identity. This one. Let's say it's 1. Now, ideally, you're supposed to rewrite the identity, but I am not doing so. I'm directly solving it. So, a is equals to 8. A is equals to 10. Now, a is equals to minus 10. B is equals to minus 10, not 10. Because if you equate this x minus 10 with your x plus b, this is x plus b. So, x minus 10 can be written as x plus of minus 10. Therefore, b value becomes equals to minus 10. At this, placing these values over here in your equation 1, we get x squared plus a plus b, which means you are supposed to add a and b. 8 minus 10 is equals to minus 2. So, and minus plus will be minus. So, this is minus 2x plus 8 into minus 10. 8 into minus 10 is minus 80. Plus minus minus. So, this is minus 80. That's your second value. Third. (3x plus 4), 3x minus 5. Now, here I'm writing the identity again, but because x is already used over here, let's write the identity something like capital X minus a into capital X plus a plus b is equals to capital X whole square plus a plus b into capital X. Because small x is already used in the question. Now, in the previous part, it wasn't an issue because this was x and your first term of your formula was also x. But here your first term is 3x and the formula is x. So there might be a confusion as such. Equating this with your given question, you can see that this part looks something like the question. Equating it, you get capital X is equals to 3x. First term of both the factors. Your a is equals to 4 and b plus b is equals to minus 5. So b is equals to minus 5. Now, placing these values in the equation, you get 3x plus 4 into 3x minus 5 is equals to 3x whole square plus 4 minus 5 into x plus 4 into minus 5. This will be equals to 9x squared minus x minus 20. So that's your final value. Next. Your fourth and the last part in this is y square plus 3 upon 2 into y square minus 3 upon 2. Okay. Now here, as you can see, these two terms are common, which was in the common term, the first part of the factors were same. But here, first part is same and second part is also same. So this looks something like x minus a into x plus a is equals to x square minus a square. Comparing these two, your left hand side looks something like this. Comparing these two left hand sides, your x is equals to y square and your a is equals to 3y2. Placing this in your equation, you will get y square plus 3 upon 2 into y square minus 3 upon 2. Replacing this value over here will be equal to x square, that means y square's square, minus a square, a is 3/2 whole square. This is equals to y to the power 4, because according to laws of indices, your powers gets multiplied, minus 3 upon 2 whole square, which is 9 upon 4. So that's your final multiplicative value. There's also one more question. More part to it. 3 minus 2x, 3 plus 2x. 3 minus 2x, 3 plus 2x. Here, it's the same thing. We are using the second equation. Comparing this with the left hand side of the second equation, your x is equals to 3 and your a is equals to 2x. Therefore, equation 2 implies 3 minus 2x into 3 plus 2x will give you 3 square minus of 2x whole square, which is 9 minus 4x square. That's your final value. Next, second question. Evaluate the following products without multiplying directly. Now, multiplying directly means 103 multiplied by 107 by the method that we've been studying since first standard. Identities, how can you place your identities? You only know algebraic identities. That means you will have to write 103 in terms of a binomial and 107 in terms of a binomial. The first part is 103 multiplied by 107. Now you can write them as 100 plus 3 into 100 plus 7. This looks something like x plus a into x plus b. We know that x plus a into x plus b is equals to x square plus a plus bx plus ab. So equating this with the left hand side, we have x is equals to 100, a is equals to 3 and b is equals to 7. Placing it in this equation, we get 100 plus a into 100 plus b is equals to 100 square plus 3 plus 7. We'll have to place 3 and 7 over here. Into 100 plus 3 into 7. So here you have 103 multiplied by 107 will be equals to 1 followed by 4 zeros plus 7 plus 3 is 10. 10 multiplied by 100 is 1000 plus 21. And whenever such questions arises, it's always better to write it one below the other and then add it rather than adding it directly initially for the first 5 to 6 questions, and then later on, once you have practiced in this arena, you can do it directly in horizontally as well. So your answer is 11021. Second, 95 into 96. Now here you have 95 can be written as, you can write it as 90 plus 5, but it makes more sense to write 100 minus 5 because 100 is easy to calculate with the zeros. Multiplied by 100 minus 4. Again, a plus b, a minus b. Here your x is equals to 100, a is equals to minus 5, and b is equals to minus 4. Therefore, your 100 minus 5 into 100 minus 4 will be equals to 100 square plus minus 5 minus 4 into 100 plus minus 5 into minus 4. Make sure that your minus signs are not dwindled and you are following exactly the right mathematical approach. Minus 900 minus minus plus 5 into 4 is 20. Always add the values first and then subtract. So 10020 minus 900. So 2 zeros, this 20 remains as it is, 20. 100 minus 9. It's better to 100 minus 9 rather than one step at a time. So 100 minus 9 is 91. Next, the third question is 104 multiplied by 96. The common factor can be 100. 104 is exceeding 100 and 96 is less than 100. So it is 100 plus 4 into 100 minus 4. Now this becomes much simpler because here you use the property x plus a into x minus a will be equals to x square minus a square. Here your x is equals to 100 by comparison and a is equals to 4. So placing it over here, you get 100 plus 4 into 100 minus 4 will be equals to 100 square minus 4 square. 104 into 96 will be equals to 1 followed by 4 zeros minus 16. Observe 16 means 2 digits. This is 10,000 subtracted by 16, which will be, observe this to be 100. 100 minus 16 will be 84. And these two terms converted into 9 nines. So that's your answer. The previous question also you will have to write after this. 95 multiplied by 96. Third question. Factorize the following using appropriate identities. The first part is 9x square plus 6xy plus y square. Now this looks something like a square plus 2ab plus b square, but only by observation. Let's see if it actually is. This can be written as 3x whole square. This y square can be written as y whole square. Now we know that when you have a plus b whole square, you have a square plus 2ab plus b square. Now if you take this value as your a and this value as your b, your middle term should be 2 times these two multiplications. So if you take 2 multiplied by a multiplied by b, let's see what you get. You get 2 multiplied by 3x multiplied by y, which is 6xy, which is exactly the value which is written in the middle. So by this basic observation, we can say that this is based on this identity. Now, this was complete rough work. On a piece of paper, you write this you'll write this formula. Based on this formula, you can say that your 9x square plus 6xy plus y square is equivalent to a square plus 2ab plus b square. Your a is equals to 3x, b is equals to y. We know that a square plus 2ab plus b square is equals to a plus b whole square. Then you place the values of a plus b over here, which is equals to 3x plus y whole square. You have to factorize, means you have to write the factors, which means these have to be written like this. That's your answer. That's the value of 9x square plus 6xy plus y square. So first the given question and then step by step on your end. Second question. Again, you have to factorize 4y square minus 4y plus 1. So this can be split as written as 2y whole square minus 2 into 2y. Now your last term is 1, so you'll write multiplied by 1 plus 1. Using the identity, this something looks like a square minus 2ab plus b square. So a minus b whole square is equals to a square minus 2ab plus b square. We get, comparing these, the a value is 2y and your b value is equals to 1. If this is the scenario, then you can say your given value, which is 4y square minus 4y plus 1 is equals to 2y minus 1 whole square, which is equals to 2y minus 1 into 2y minus 1. Factors are always linear polynomials to the power 1. Third, x square minus y square divided by 100. This can be written as x square minus y upon 10 whole square. Now this looks something like a square minus b square. We know that a square minus b square is equals to a plus b into a minus b. Comparing, we get a is equals to x and b is equals to y by 10. So this value becomes equals to x minus y by 10 into x plus y by 10. Next, fourth question. Expand each of the following using suitable identities. The first part is x plus 2y plus 4z whole square. Here the identity used is, using identity of a plus b plus c whole square. We know that this value is equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Therefore, the given identity becomes x plus 2y plus 4z is equals to, comparing, we have a is equals to x, b is equals to 2y and c is equals to 4z. Therefore, this value becomes equals to x square plus 2y whole square plus 4z whole square plus 2 times x into 4z plus 2 times x into 2y plus 2 times 2y into 4z. This is equals to x square plus 4y square plus 16z square plus 8xz plus 4xy plus 16yz. So that's your final answer. All you have to do is equate your given question with this identity, compare, get the values of a, b and c, substitute and come up with the answer. I'm not going to write the identity in every part. I'll assume that you know it, you've like learned it by heart, or you can write it somewhere and refer to it. Second part, 2x minus 5 plus z whole square. Now in your identity, it is a plus b plus c. That means all a, b and c have positive values. Here you have minus 5. So a will be equals to 2x, b will be equals to minus 5. The minus term goes with your variable. And c will be equals to z. Placing this, we get this result will be equals to 2x whole square, which is 4x squared, plus minus 5 whole square, which is 5 square, plus z square, plus 2 times ab. 2 times ab. 2x into minus 5. This can be written as minus 4y, minus 4x5. So I'm directly writing it minus 4 times x1. Next term is minus ac, sorry, plus 2ac, plus 2 times 2x into z, which is equals to 4xz. So here it is 4xz, plus minus y into z, which is into 2bc, which is minus 2yz. Minus 2yz. Next, one second. Third term, third question. Minus 2x plus 3y plus 2z whole square. Here the first term is negative. So your a becomes minus 2x, b is equals to 3y, c is equals to 2z. Placing it in the formula, for this we get minus 2x whole square, which is 4x square plus 9y square plus 4z square plus 2 times ab. Now a is negative, so minus 2 times ab, x into y, 2 into 2, 4, 4 3s are 12, plus bc, 2 times bc, both are positive, so plus 2 times yz are the variables, 2 into 3, 6, 6 2s are 12, plus 2 times ac, a is negative, so it is minus 2 into 2 is 4, 4 into 2, 8, xz. Next. Fourth question is 3a minus 7b minus c whole square. Now, your formula is written in terms of ABC. Whenever ABC, the variable in which you have written the formula, in the variables in which you know the formula are already mentioned in the question, change the variables of your formula. Always change the variables of the formula to avoid any confusion. So here your formula can be like x plus y plus z whole square is equals to x square plus y square plus z square plus 2xy plus 2yz plus 2x. If x, y, z are used in the question, you'll write the formula in terms of ABC. So this becomes equals to x value is 3a, so 9a square plus 49b square plus c square plus 2 times ab. Here you should have negative minus 6 into 7, 42 ab. Now, if you have any problem with this, you can ask me in the comments, but I'm directly writing the answer for the rest. For the fifth part, you have minus 2x plus 5y minus 3z whole square. Your A part is minus 2x, B part is 5y, C part is minus 3z, and this part becomes equals to, placing these values in the formula, 4x square plus 25y square plus 9z square minus 20xy minus 30yz plus 12xz. For the sixth part, you have 1 upon 4a minus 1 upon 2b plus 1 whole square. Now, third value is 1, but that shouldn't change your assumption. Sorry, that shouldn't change your approach. Comparing it with the formula, we'll use this xyz formula. Your x value is equals to 1 by 4a or a upon 4. Y value is equals to minus b upon 2 and z is equals to 1. All you have to do is place in the formula. You will get 1 by 4 whole square, which is a square upon 16 plus b square upon 4 plus 1 square is 1 plus 2 times xy. Xy means this is minus 2 times ab upon 4 into 2 and 2 gets cancelled. You're left with minus ab upon 4 plus 2 times ac or xy, xz. So 2 will get cancelled with 4, like 2 part of 4, and you're left with plus a by 2 plus 2 times, which is minus b by 2 into 2. 2 gets cancelled, b into 1 is b. So this is your final answer for this part. We'll continue the rest of the questions of this exercise in the next class. Thank you.